Linear functions and models. Suppose that f of x equals 2x minus 3 and g of x equals negative 1/2 x plus 2. We're going to find the following. First of all, the 0 of g. Recall that a 0 is an input that makes the output equal to 0. So the way we find a 0 is by taking the formula that defines the function, which in this case is negative 1/2 x plus 2, and setting it equal to 0, indicating that the output should be 0. Then we can solve this equation. We can solve this by, maybe we'll first decide to add this 1/2 x term over to the right just to make it positive. That way we'll have positive terms on both sides. That gives us 2 equals 1/2 x. And next we can multiply both sides by 2, which is the reciprocal of 1/2. I'll call that 2 over 1 here, and I'll just call it 2 on the left-hand side, so that this gives us, the 2's cancel, x equals 4. So the 0 of g is just the value 4. Going on to the next question, we are asked to solve the equation f of x equals 3. The way I'm going to interpret this is that up above I have the definition of the function f of x equals 2x minus 3. Down here I have an equation. The way I solve this equation is by substituting into it with the algebraic expressions. So in place of f of x, I'm going to put its definition, 2x minus 3. And then the rest of the equation is already possible to manipulate algebraically. The equals 3 doesn't have to change. So I change this into an algebraic equation so that I can follow basic steps of solving a linear equation here. Again, I'm going to start by isolating that x by adding 3 to both sides. Giving me 2x equals 6. If I divide both sides by 2, I'll be done, and I get x equals 3. So my value here then becomes 3 for x. That means that f of 3 is equal to 3. And that tells me that I have an x and a y. So that for a point on the graph of f, I would put the coordinates 3, 3 for my x and my y. Finally, I'm asked to solve the inequality f of x is less than g of x. And just like how I set up the equation in the previous example, I'm going to substitute into this inequality with the expressions that define the functions f and g. F of x, we decided, was the expression 2x minus 3, and g of x was negative 1/2 x plus 2. And then finally this inequality symbol is still a less than, so that I get a linear inequality now that I can solve. And it looks like maybe clearing fractions would be a good plan here. We've got only one denominator, which is 2. So my LCD is 2. And I'm going to choose to multiply both sides of this inequality by 2 in order to clear the fractions. Multiplying both sides by 2 gives me 4x minus 6 is less than minus 1x plus 4. Again, I did distribute that 2 to both terms on each side of this inequality. 2 times negative 1/2 was probably the trickiest little computation that we did here, but if we can't do that in our heads, we can just do it off to the side as negative 1/2 times 2 over 1, coming through and canceling the common factor of 2. to get 1, so that equals -1, and that is my -1 here. That's the coefficient of x in my equation. Now I can finish this by getting the x terms onto the same side by adding x to both sides, and by getting my number terms both onto the same side by adding 6 to both sides. So that after moving terms I end up with 5x is less than 10, and then dividing both sides by 5. Since 5 is positive, that does not flip the inequality symbol. I get x is less than 2, which I can express either in interval notation as the set from -infinity up to 2, or using set builder notation as the set of all x such that x is less than 2. Finally, I'm asked to graph both f and g on the same coordinate system. So I've written down both of these formulas again so that we can work with them. These are both in the form y equals mx plus b. Remember that this f of x is just the same as y. So in order to graph a function, we can immediately just change it to an equation, or just mentally change it to an equation, so that this is in the form y equals mx plus b. My slope is +2, I'll write that as 2 over 1, and my y-intercept is -3, so I'll write that as the ordered pair 0, -3. Coming over to my grid, here's my y-intercept, and then using a slope of +2, that's a run of 1 and a rise of 2, I can get a few more points, and then draw my line. Going on to the function g of x, I would use the same method here. I have a slope of -1/2. So that's going to be a rise of 1, a run of 2, and making sure that as we read it from left to right it is going down, and a y-intercept of +2, or the point 0, 2. Starting from my y-intercept, I'm going to use a run of 1 and a rise of 2, making sure that as I read from left to right, this line is pointing in the downward direction because my slope is negative. I get a few points here, and then I'm ready to draw my line. So at this stage I've graphed both lines. I am done with the problem, but we're going to just take a moment to relate this graph to some of the information that we found in the previous questions. First of all, we found that the 0 of g is equal to 4. So let's look at the graph of g. This green one here is my g, recall. And the blue graph is my f. I should have labeled these when I drew them. Now looking at the 0 of g that we see from the graph, right, we can also see that that's the x-intercept, and we know that the x-intercepts are the same as the zeros. Just reinforcing some of the things that we already know. Coming up again, we also found that f of 3 is equal to 3, so that the point 3, 3 should be on the graph of f. Let's look at the graph of f and see if we can see the point 3, 3. Sure enough, right here we see the point 3, 3 on the graph of f. And there's one more thing that we want to observe that we're not really going to be ready to do a lot with in this course, but in college algebra this comes up an awful lot. We solved the inequality f of x is less than g of x. If we wanted to interpret this in a graphing setting, we could consider that inequality to say below, because less than would mean below. If I look now at these two graphs, and I highlight the portion of f that's below g, that would be this part down here. If I were to translate that into a set of x values, it looks like it would come up to x equals 2, but since that arrow kind of goes off to the left, my set of x values would have to also go off to the left. And the set that I just graphed here on the x-axis happens to just match up with the exact solution from negative infinity up to 2. Although really I should have had an open circle here because of the strictly less than. So this happens to just match up with the solution set to that inequality. This is not a coincidence. This is in fact a method of solving inequalities that we go over in college algebra that's called solving by graphing or solving graphically. So the graphs of these two functions do actually relate to an awful lot of the information that we just found about them.